All right, in this video, I'm going to go over the process for finding the formulas of ionic compounds as well as the names of those ionic compounds. We're going to start with a really simple example over here, calcium and chlorine. I'm going to separate this out. The first part of the process with ionic compounds is always finding the charge of each element. In this case, we have calcium and chlorine. What we would find by counting from the periodic table from the left over, that calcium has 2 electrons in its valence shell. It's likely to lose those 2 electrons and therefore form a charge of +2 or 2 plus. Chlorine, on the other hand, has 7 valence electrons. It's more likely to gain 1 electron instead of losing all 7. So therefore, it would have a charge of -1. Now, to find the ionic formula for this compound, we would have to figure out how many of each element or ion we would need to balance out the charges. Right now, they're not balanced. Calcium has a +2, chlorine has a -1. The way to fix this would be to have 2 chlorine ions, each with a charge of -1, to balance out that calcium. However, there is a trick we can use where if we switch the charges on each compound, it'll tell us the amount of each ion. So if our calcium has a charge of +2, it tells us we need 2 chlorine ions. If chlorine has a charge of -1, it tells us we need 1 calcium ion. So my formula will be 1 calcium, and we do not need to write the 1 as a subscript, and 2 chlorines. So we switched the charges, and that got us the amount of each compound. That's how we find the formula. For the name, we have to do one little trick, one little change. Calcium, the cation or first atom in this, keeps the same name. So calcium is just calcium. Our second ion, our anion, the negatively charged ion, chlorine, it keeps its name, but it changes the ending to IDE. So instead of calcium chlorine, we have calcium chloride as the ending. That's our really simple example, when we have 2 ions with defined charges. Our second example, iron and chlorine, or FeCl, the first part of the process is almost the same. However, this iron, it has multiple options of charge. It is a transition metal in the middle of the periodic table, and because it has multiple options, it can have multiple different compounds with chlorine. We know the charge on chlorine, it's always -1. But iron, if we check our chart, can have either a +2 or a +3, and we have to determine which it is depending on what the formula might be. But in this case, I'm going to give us the charge. We'll say that this iron has a charge of +3. But remember, it could also have a charge of +2. And actually, I will write that possibility above. But we're going to stick with iron as a +3. Our first trick can get us the same formula as before. Fe1, because there's -1 with the Cl. Switch the charge with Fe, we see Cl3. And this should make sense. There are 3 Cl's, each worth -1. There's 1 Fe worth +3. That will balance out to an overall charge of 0. If we add up 3 -1, -1, -1, we'll get to an overall neutral charge. Now the name changes a little bit. The first rule stays the same. It's still going to be iron chloride, again, changing the ending of that anion to IDE. But we need to specify which iron we're talking about. Are we talking about the +3 iron or the +2 iron? Because in this example, we're talking about the +3 iron, we have to state that in the name. That way, whoever's reading the name knows, oh, this is iron with a +3. And the rule for this is pretty simple. After the iron, and in between the iron and the chlorine, we need to state the charge, but we use Roman numerals. So we'll use the Roman numeral for 3 to state that we have iron 3 chloride. This applies to any cation, the positive ion, which can have multiple charges. Iron is one of these cases. so we need to state the charge. With something like calcium, it's always going to be +2, so we don't need to state that charge. We have one more rule, and it's kind of simple, but it can get a little bit tricky sometimes. Notice that we have calcium, what we started with, that +2 charge, and we have this ion here, SO4, that is polyatomic. There are multiple atoms in this ion. These you won't have to learn how to use in this class, or how to calculate the charge, but you will need to construct the ionic name and formula for these. But as far as the charge, if you look on your chart, you'll see that this is called sulfate, and it has a -2 charge. So let's get the formula. CaSO4. If we were to switch the charges here, we might think that we need 2 CAs and 2 SO4s, but actually we're already balanced. Ca has a +2 charge, SO4 has a -2 charge, so they're already equal and balanced. If we added these up, they would add to 0. So the formula is actually pretty simple. It's just CaSO4. The name is also very simple. Calcium, as always, keeps its name. We do not need any kind of Roman numeral in parentheses here because calcium is always +2. And this other group, this SO4, luckily, this rule is pretty easy. It also just keeps its name. If you check your chart, you'll see that this is called sulfate. And so this just becomes calcium sulfate. We don't have to change the ending. These polyatomic ions keep their name. Now let's look at our last example. A lot of this is going to look familiar. In our last example, iron, Fe, and SO4, that's sulfate, we're going to have to combine those slightly more difficult rules. In this case, I'm going to stick with the same iron. I'm going to stick with iron 3. And our sulfate from our chart has a charge of -2. We will need to switch those charges. We're going to need 2 of the irons and 3 of the sulfates. Now, the way we show that, because sulfate has multiple atoms, the way we show that we have 3 sulfates, do my irons first, iron 2. The way we show we have 3 sulfates is we keep that sulfate together as a group with parentheses. We say the whole sulfate, SO4 in parentheses, we're going to need 3 of those. In other words, we will need 3 sulfur atoms and 12 oxygen atoms, but because they travel as a group, we keep them in parentheses. And for the naming, we just have to combine our rules. Fe is iron. Because we're talking about iron 3, and iron has multiple options for charge, we'll state iron 3. And for the last part, we just got to give the name of the sulfate. Because it's our polyatomic, we don't need to worry about changing the ending. And that's really it for finding the formulas and names of ionic compounds.